In this video, I'd like to remind you how to find an x-intercept and a y-intercept and apply that to the graphs of quadratic functions. So I've already defined x and y-intercepts back when we worked with equations of lines, but just to remember, an x-intercept is the point where a graph crosses the x-axis. A y-intercept is the point where a graph crosses the y-axis. So to find these intercepts, you let the opposite value equal 0 and you solve for your variable. Let's find the intercepts of f of x equals x squared minus x minus 2. So to find the x-intercept, we're going to let y equal 0, which means this function is going to be equal to 0. This represents the y value or the output value here. So we get this equation, x squared minus x minus 2 equals 0. To solve for the x-intercepts of quadratic functions, we're going to be solving quadratic equations where they equal 0. So you could choose any method to solve this one. This trinomial looks factorable, so I would like to solve it by factoring because that tends to be easier. I can say x minus 2 times x plus 1 equals 0, and then I set each factor equal to 0, which means x equals 2 or x equals negative 1. These are both the x values of x-intercepts. So the x-intercepts are 2, 0, and negative 1, 0. Those are our final x-intercepts. Remember I said earlier that the solutions of this quadratic equation are the same as the zeros of the function or the x values at the x-intercepts. So it makes sense that to find x-intercepts, we're solving this quadratic equation. Now the y-intercept is a little more straightforward. To find the y-intercept, we let x equal 0 and we solve for y. But because x is the dependent variable here, it's just a matter of plugging in x equals 0 and solving for y here. So we would say y equals 0 squared minus 0 minus 2. And when I simplify that, I get y equals negative 2. So what's our y-intercept? Well, it's just the point 0, negative 2. The y-axis is a vertical line, and remember that every function only crosses a vertical line in one point. So it makes sense that we will only ever have one y-intercept, and the y value of that y-intercept is always the constant term here because you're plugging in x equals 0, and that neutralizes all the variable terms. So if you want to know really quickly what's the y-intercept, just look at the constant term. That's the y value. To find the x-intercepts, as we discussed in an earlier video, there could be two x-intercepts, which means there's two solutions to this equation, but there could also be one x-intercept or there could be no x-intercepts. It might be impossible to solve this equation. In that case, the graph of the function would be completely above or below the x-axis. It would never cross it, and so we would not see an x-intercept. Let's look at one more example of finding intercepts. We want to find the intercepts of f of x equals x squared minus 6x plus 4. In an earlier video, we sketched some of the other properties of this quadratic function. I'm starting with the y-intercept just because that's a little easier. We let x equal 0 and we solve for y. So that's just a matter of plugging in x equals 0 to this function. All the variable terms work out to 0 and we get y equals 4. So our y-intercept is the point 0, 4. We will always be able to define a y-intercept for a quadratic function. To find the x-intercepts, we're going to let y equal 0, which means the output of the function equals 0. And we end up with this equation, x squared minus 6x plus 4 equals 0. Now, this trinomial cannot be factored in this case, but I still need to solve this equation for x to find our x-intercepts. I'm going to solve it by completing the square. So first I'm going to move the variable term to the other side, and then I'm going to add some amount to both sides that will create a perfect square on the left. The amount I need to add is -6 divided by 2, which is -3, and then square it. So -6 over 2 equals -3. -3 squared is +9. So I need to add +9 to both sides. And I get this. X minus 3 times x minus 3 equals -4 plus 9, which is 5. So I have the equation x minus 3 squared equals 5. I've written it as a perfect square. Let's take a square root on both sides, and I get x minus 3 equals positive or -√5. So when I finish this solution by adding 3 to both sides, my solution will look something like this. X equals 3 plus or minus √5. How do I interpret that as x-intercepts? Well, remember, this represents two different numbers. One of these is the numbers 3 plus √5, and one is the number 3 minus √5. I'm going to keep them in their rational form, although it might be easier to remember that they're different numbers by converting them to decimals on a calculator in this case. But my x-intercepts are whatever this value is, 3 plus √5, comma 0, and 3 minus √5, comma 0. These are the 2 points where the graph crosses the x-axis.